Alright, ladies and gentlemen, for this presentation, we're going to take a look at pedigrees. So pedigrees, as you can see right here, are actually our way of tracking the dispersion of traits from generation to generation in a family. So there's a couple of things that you need to know about pedigrees before we can get into what actually happens. So the first thing is that pedigrees are read in a certain way. So the circle right here is a female, and you could always tell they're females because they're circles. And the square over here is a male. You can always tell they're males because they're squares. This line that connects the two means that they have a reproductive pairing. So that means that those two individuals have interacted in such a way that they have children. This line right here and this line shows you the children that reproductive pairing has. So in this instance, you have a mother and a father, and they have had two children, one daughter and one son. Okay? So that's what the lines, the circles, and the squares mean. Now you'll notice on the pedigree, some of the squares are empty and some of the squares are filled in with dark colors. And so the squares that are empty mean that they do not have the trait. And the squares that are filled in with dark colors, they have the trait. And we're always looking at pedigrees for one trait at a time. So you could look at a pedigree for a family, for one trait, and then if you wanted to see another trait, you'd look at a different pedigree. Okay? So these are the basics of reading a pedigree and what this means. Now, a couple other things about pedigrees. We label generations with Roman numerals. So you see here, like the ultimate first parents that are, generating this whole family tree right here is 1. The next generation is 2, and 3, and 4. And you can always tell generations by doing this. So above that line is generation 1. Above that line is generation 2. Above that line is generation 3. Above that line is generation 4. All right, so you read the generations across. Now, you'll also notice that I've put individual numbers here. So what we will sometimes do in a pedigree, and sometimes you won't see this done, but what will happen is the individuals will be given numbers, and that's just so you can tell who it is. So for instance, if I said generation 3, individual 3, you would know I was talking about this girl right here. If I said generation 4, individual 3, you would know I was talking about this girl right here. So it's just another important understanding to know exactly how it is that we notate what goes on in a pedigree. So, a couple things about pedigrees. We're going to talk about some of the things we look for and some of the things that we can use to see that. So, typically we use pedigrees to look at the expression of a trait in a family, decide what the trait is, and once we know what the trait is, we can decide how the trait is passed on. And in fact, there are some pedigrees where that kind of information can be used to actually determine whether or not some individuals, what their genotype actually is. So the first thing I want to talk about is two types of ways that traits can be passed on are autosomal dominant and autosomal recessive. All right, so autosomal dominant is just the organism is a dominant trait, or autosomal recessive is a recessive trait. That word autosomal comes from the fact that there are two types of chromosomes that an organism has. They're autosomes and they're sex chromosomes. So for instance, in human beings, the autosomes are chromosomes 1 through 22, and the sex chromosomes are chromosome 23. So all organisms that sexually reproduce have autosomes, and so we refer to autosomal dominant because it's a trait that is not passed on the sex chromosome and it's dominant, or it's a trait that's not passed on the sex chromosome and it's recessive. All right, so you look at this pedigree and the question becomes, well, how do I figure out whether it's autosomal dominant or recessive? And what you always want to look for when you're trying to decide whether a trait is dominant or recessive is you want to look for a set of parents, like we have right here, and that set of parents does not have the trait because their circle and square respectively are not filled in. But if you'll notice, they have children that have the trait. And so what this means is that the parents had to be able to carry the trait, and so they had to hide it. And since they had to be able to carry it, and they had to be able to hide it, then that means that it has to be recessive. Okay? Up here, this information is not enough. All right? That woman is possessing the trait, but she could have been that and just by luck not passed it on to her children. But down here, there's no way for these two parents to possess the dominant trait and not pass it on. And that means that these parents were both this. They had to be, because the father had to give the little recessive trait here. The mother had to give the recessive trait here. The father had to give the recessive trait here. The mother had to give the recessive trait there. And so that's the number one way that you can look at dominance and recessiveness on autosomes, is look for a set of parents that do not have the trait and pass it on. And if you can find that, then you know it's autosomal recessive. Now, one of the other things is what's known as sex-linked recessive. This one's a little harder to spot, because it's really hard to pick out, is it just recessive or is it sex-linked specifically? But what you will notice here is, first off, the majority of the people who possess the trait are males. 1, 2, 3, 4, 5. And you will also note the only time you see a female with the trait that's in the family, this one doesn't count because she married into it, is when both parents have it. Think about it. The father here had to be recessive for the trait. The mother here is double recessive for the trait. That means that the father gave the recessive to the daughter and the mother gave the recessive to the daughter. Now, it is possible for a daughter to have a mother that's normal, but it's easy to tell it's sex-linked recessive if you have a pattern where there's a lot of males with it, and then females that seem to have it either marry in or they come from two parents that have the trait. So here you have an example pedigree, and you're looking at it and you're saying to yourself, all right, so how is this passed on? Is it sex-linked? Is it autosomal dominant? Is it autosomal recessive? So the first thing I do is I check the males and the females. So I got 1, 2, 3, 4, 5. 6 people out of 20 that have this trait. And of those 6, 2 are females, 4 are males. That's not a really broad distribution. My guess here is that this is not really sex-linked. Okay? And if you look here, I have a female that doesn't have the trait and a daughter that gets it. And it's not a guarantee, but that's another indication to me that it is not sex-linked. And what you see here is a mother and a father that don't have the trait, and you have a child that does. Okay? Over here, you have a father that does have the trait, and he comes from 2 parents who don't. And so what I end up seeing here is this is most likely autosomal recessive. And it's possible it's X-linked recessive, but it is unlikely. So reading pedigrees is really just a matter of process of elimination, trying to decide what belongs where, who goes with who. And it really takes some practice. So those are just some of the basics, and we'll actually work on some of that as we go spend time in class. All right.